Hey YouTube, in this video we're going to show that the function z equals e to the x times the sine of y satisfies Laplace's equation. Let's go ahead and work it out. So to do this, all we have to do is take the partials and plug them into this equation and make sure we get 0. So I'm going to go ahead and write down z again. So z is equal to e to the x sine y. And so when we take the first partial derivative of z with respect to x, we treat all of the y's as constants. So sine y is a constant. And the derivative of e to the x is just e to the x. So we get e to the x, and the sine y just hangs out because it's a constant. Then when we do it again, same thing happens, right? It's just a constant, so the derivative of e to the x is e to the x, and that sine y just hangs out. Pretty easy. All right, now we have to do the same thing for y. So when we take the partial of z with respect to y, this time all of the x's are constant. So in particular, e to the x is treated as a constant. So it hangs out, and we take the derivative of sine. So the derivative of sine is cosine, so we get e to the x, and then we get cosine y. Then when we do it again, we get the second partial with respect to y. Now the derivative of cosine is negative sine, right? So again, the e to the x hangs out, so it's negative e to the x sine y. All right, so now all we have to do is plug these into the equation, and we should get 0. And we do. I just noticed we do get 0. So plugging everything in, let me write it again. So when we have the second partial of z with respect to x plus the second partial of z with respect to y, that's equal to, well, this first piece here is right here, so that's just e to the x sine y, plus, and this piece here is right here, so that's parentheses negative e to the x sine y. These are opposites, so this is equal to 0, so we have shown that this function satisfies Laplace's equation. Thanks for watching.